we are moving on to standard form, which is the last official form. We have three forms of an equation of a line. Slope-intercept, point-slope, standard. So slope-intercept was y equals mx plus b. Point-slope was that y minus the y you're given is equal to your slope times x minus the x you're given. And today we have standard form. Ax plus by equals c. You need to know some properties about standard. So you need to be familiar with all three forms. Slope, intercept, pretty much how to graph it. Do you know how to graph from slope, intercept? How would you graph that? Right?
You put the point at +2 and you go up, down, over.
You see? So you're analyzing point and slope, point and slope. All right, what about this one? How do you graph that? Gatlin?
You distribute.
Okay, that's a good call. So Gatlin said you distribute and then get y alone. Personally, I wouldn't, because I would see this fraction, I would mess it up. I know me. I would feel like really insecure about that fraction. So you can actually pull the point out and use the slope. So the point was -1/4. My slope -3/2. Okay, that's a way to do it. I don't typically do that all the time. Standard form, sometimes they give it to you like that. They're going to say things like intercept. So I want you to write that down. That's the key word. If it's in standard form, they're going to say, what are the intercepts of this line? It's super easy to do. And then once you know the intercepts, it's super fast to get it. Properties on standard. X and Y are on the left. Yep. X is always before Y. So X and Y are on the left. X is before Y. And there are never any fractions. Three properties. X and Y are on the left. X is before the Y, and never any fractions. We're going to get into that more next week. Today we're just going to check out the intercept strategy. So you're given a line on that next page. And I want you to make a circle on the x-intercept. X is this axis, Y is this one. Where did this line cross the x-axis at? Make a dot. You see? I just went right through the x-axis. The y-intercept, make a dot at the y-intercept. That's how you're going to graph a line today. You're going to find out where they're going to cross, and then you don't even use slope. Then you just connect them. But you only do that if x and y are on the left. So here's my strategy here. What's the y value right here? Nuh-uh. My x is negative. Did I go up or down at all? No. So the x-intercept, y equals 0. Y disappears on the x-intercept. On the y-intercept, what is the x value? How much did I go over? Anything? No. I just went up. I went over 0 and I just went up. So at the y-intercept, x is 0. So each intercept, the other variable just cancels out. Okay? That's the property. Here's a little skeleton on how I solve these problems. I always make a little T-chart. I say, okay, what's my x-intercept? What's my y-intercept? My x, I know that y is 0 or y cancels out. My y, I know that x is 0. I don't want to get too into the y. I told you why that is right here. We visualized y. So let's just apply it. Now that we know why, let's just do it without asking. and solve. That's all you do. Cover up the opposite variable and then solve. That's the main idea here. I cover up the opposite and I solve, because covering up cancels it. So this line here, this first one, 3x plus 4y equals 24. You can get y alone if you want, but guess what? Lots of mistakes happen. Lots of mistakes happen with getting y alone. Kids mess it up all the time. So we're gonna find how to graph it without. So at the x end, y is 0. So that means I cancel out the y term. 3x equals 24, x is 8. So my line crosses the x-axis at 8. Now my y-intercept, what is 0 at my y-intercept? X. Yes, x. So you cancel out, if I'm looking for the y, I cancel the x. So I get rid of that whole term. Do you see what I did there? I covered it up. I usually use my fingers when it's the worksheet to cover it up. 4y equals 24. Y is 6. Now let me show you how I would quickly graph this line. It crosses my x-axis at 8, about right there. It crosses my y-axis at 6, about right there, and you would connect it. That's why we care about intercepts. It's a quick way to graph without using slope-intercept. Okay, next one. So my x-intercept, what do I cancel out? Tell someone next to you. What am I going to cancel out? Hunter, what do I cancel out? Y, I'm going to get rid of y. Get rid of that thing. There, that's what I have. So my x-intercept, I cancel out the y and I have negative 2x equals 20. X equals what? Negative 10? Yes? Do you agree? Kinda. Okay, moving my little box here. My y-intercept, what am I going to cancel out on my y? X. So I'm going to get rid of that x term. I'm going to cover it up. You're not going to have a movable box to do it. You're going to have your finger to cancel it out. You'll want to do it. Negative 4y equals 20. Y equals what? Got it. Negative 5. So how I would graph this, I would make a dot at 10 for the x, a dot at negative 5, connect. That's why we're doing this. It's really fast. It's fast to graph because a lot of kids, if you get y alone, look at all those negatives, you're going to mess it up accidentally. Okay, you try the next two. Okay. So the next line, x plus 3y equals 9. The vocab you're going to hear is identify the intercepts. So x-intercept, I cancel the y. So I'm going to block off the y term. And I just get x equals 9. That's easy enough to do. The y-intercept, I cancel out, what is happening? I cancel out the x term. Okay, so I have 3y equals 9. Y is 3. Again, the purpose of this is you can quickly graph. Now I could graph this line, y3, x9. It would look something like that. It's a very messy graph. Please know that you would scale it appropriately. Okay. Accent, I cancel out my y. So 5x equals 9. X is 9 over 5. That's okay, it's what? Almost 2, not quite 2. And y int, do you see see that negative in front? It's negative y equals 9, which is like negative 1. Divide by negative 1, y is negative 9. So this would look like 9/5, which is a little less than 2, negative 9, a graph like that. Okay, so learning objective number 1 today, identify intercepts. How do you feel at identifying intercepts? Okay, just cancel out that opposite variable. Cover it up with your pinky or your finger or a piece of paper or your eraser. It really helps, I promise. Next, graphing. Last thing, last target. Graphing I already taught you. I've shown it to you when I showed you why we identify it. So all you do, identify the intercepts and connect. That's all you do for graphing. So if I say graph the following line, before you would have to get y alone and then plot the y-intercept and use the slope. Now you just need to know the intercepts. So I do my table. And I'm making my little box to cover up, maybe. Maybe not. Okay, that's going to be my little cover-up box. Whoa. Holy moly. Got it. Okay, so what am I going to cover up for the x-intercept? I'm going to do the negative 2y. I'm covering it up. So I get x equals negative 2. For the y-intercept, I'm covering up the x. So I have negative 2y equals negative 2. Y is 1. So now I plot. Negative 2 is my x. 1 is my y. Connect. That's it. There's my line. It's done.